All right, today we're going to start quadratics, and we're going to do a couple things with quadratics, which is going to take probably at least a week. We're going to start with a basic introduction of what is a quadratic. We're going to start some simple factoring, which you've done before, I know, but I'm going to get you back to where you were at some point in time. Then we're going to end up solving quadratics, but we're not there yet. We're just factoring. So these are expressions today. There should be no equal signs. We've done linear equations already, something like y equals mx plus b. And those are linear terms, or linear equations, I should say, and they always have only one solution. Quadratics are a different animal. They take the basic form of ax squared plus bx plus c. Where a, b, and c are numbers, and then the ax or the x squared and the x stay there. Eventually, we're going to turn that into an equation and set it equal to 0, and then solve it. But for now, we're just working with expressions. Yeah. What does that look like if you graph it? Like a U. You know the technical name of that? You look up it. Very good. It's parabola. That's if it's an equation. We can't graph that unless we know what it's equal to. And since we don't know what it's equal to, we'll save that for later. Okay, and we'll do some graphing. We'll see what they look like, how the numbers affect it. Right now, we just want to be able to break it down. Okay. So, before we start attacking the quadratics, we want to talk about this. Greatest common factor. The single biggest problem that people run into when working with quadratics is they forget about the GCF. So they try to factor some big, scary quadratic when in fact their life would be much easier if they just recognize the GCF. Okay. So, for instance, we'll call this number 1. Whoops, that's a squared. We'll start with something simple. Evan, what's the GCF here? Well, both expressions. Let's get some terminology under control so we can all be on the same page. This is an expression. We've talked about that, right? What are each of these things called? Do you remember?
Variables?
No. We'll break it down in a second. Terms. These are terms. And the terms, Sean, are made up of two parts. What's this thing in that term?
The variable.
The variable, and what's the two called?
The number.
And that number has a name. No?
No.
Right? Coefficient, right?
Oh.
Okay. So the whole thing is an expression. The expression is made up into terms. The terms are the things that are added and subtracted. And then each term is broken into a variable, a coefficient, and also, I forgot to mention the exponent there. What's the exponent on this 6x term? So, 1, correct. Okay. All right, Evan, back to you. What's the GCF between each of those two terms, the 2x squared and the negative 6x?
6.
Nope. Because 6 doesn't go into 2 even.
12.
Nope. You're thinking least common multiple. We want GCF. What goes into both of those?
1.
Yes. What else?
2.
Good. What else? In other words, what can I factor out from both of those terms? Cece? 2x. Good.
Yeah.
Factor out a 2x out of 2x squared. What do I leave behind? X. Factor out a 2x out of negative 6x. What do I leave behind? Negative 3. Thank you. Be careful. There we go. GCF. Now, why do we care about that? Well, number 1, it's going to make your life a lot easier. Number 2, later on when these become equations, it will make your life easier solving because now we have two things that multiply together to give you some other number. But we'll get to that later. Okay? Number 2. What's the GCF? 3AB. How'd she do?
I think she did pretty good.
When I take a 3AB out of the first term, what do I leave behind? A. When I take a 3AB out of the second term, what do I leave behind? Good. If that's the GCF, then when you're done, this stuff inside parentheses will have no other common factors, which it doesn't, and also up here in the first problem. Okay, so number one, GCF. And that's true of whether we're dealing with linear terms, quadratic equations, cubic equations, quintics, whatever, however complicated we get, the first thing you want to do is get that GCF out of the way. And you know this, right? Awesome. Page 2. What happens then when we actually get into some quadratics? So let's do the following. Okay. So we got a quadratic. How do I know it's a quadratic? Good. And in fact, it's 2. Have I talked about the term degree before? So we all remember that the degree of that, it's not equal, the degree of that expression is 2 because the highest exponent is a 2, which makes it a quadratic. Okay. And we can't solve it because it's not an equation, but we can simplify it because it's an expression also known as factoring. And this will start coming back to you. You might already realize how to do it. It might start coming back to you as I work through it, but I'm going to break that quadratic into 2 parentheses. This isn't an exact science, and in fact, at some point you're going to guess and check with this, but I'm going to start you slow. All the problems tonight on the homework, when you have to factor a quadratic, will have a leading coefficient of 1. You understand what that term means? It means my A term, right here, is actually 1. Then in the days to come, we'll put a number in there so that you will no longer have a leading coefficient of 1, so it gets a little bit more complicated. And you know this, right? What does that stand for?
First, outside, inside, last.
Close enough. Good. We're going to focus on this part, the OI term. And you'll see why in a second. Okay. So going back to factoring this puppy, these first 2 terms in parentheses here and here have to be 2 things that multiply together to give me the first term. Well, there's really only one way to do it. What is it?
It's just x.
Okay. Now, I could do x squared times 1, but that would be ridiculous. It won't get me anywhere. When we have a leading coefficient of 1, then it's a lot easier because now I need to put 2 numbers in there. First of all, let's talk about the signs. Will the signs here be plus plus, minus minus, minus plus, or plus minus? Okay, let's create a new screen here. X squared plus bx plus c. First scenario. Everything is positive. What are the signs in here? Plus plus. Has to be. No other options.
Okay.
Number 2. ax squared minus bx plus c. What are the signs?
Minus plus.
Plus minus.
Minus minus. Because these 2 numbers have to multiply together to give you a positive answer, but they have to add together to give you a negative answer. Oh. It's not that big of a deal. It's not like I told you the secret of life or anything.
It is a little bit,
Okay, now I'm getting fancy in my notation. The third scenario is if the second term, the B term, is positive or negative, but the last term is negative. In that case, it has to be
plus minus.
plus minus. Or minus plus, it's the same thing. Okay, so those are our 3 scenarios. If we go back to this screen then, what do I have? Plus plus, minus plus, or minus minus?
Plus.
Plus minus. Now to fill in the numbers, I need factors of 3 that when multiplied together give me -3, but when added together give me -2. What are the factors of -3? -3 and 1.
-1 and 3.
-1 and 3. Are there any other possibilities? No, so we got to figure out which one it is. So I'm going to do it incorrectly first to show you what happens when it's wrong. So I think it's going to be a 3 here and a 1 here. All right. My first terms check out okay, and because I set it up that way, I'm not even going to bother checking the first and last terms. I'm just going to focus on the OI term. So now I'm going to check the OI term. The outer term are these two multiplied together. -1 times x is -x. Then I'm going to check the inner term. 3 times x is 3x. Add those two together, I get 2x. Is that good or bad?
Bad.
That's bad because it's got to be -2x, so I screwed up.
You were really close though, so good job.
Thank you for the encouragement, Jack. That makes me feel much better about myself on a Monday morning. It's a feel good all around. Okay, so I screwed up, so I'm going to fix it. I'm thinking that it might be +1 minus 3. Okay. So check the OI term. -3x plus 1x is -2x. I'm done. Okay. Good. It factors and it works correctly. Okay. This looks familiar, right? Okay, good.
A little bit.
No, hold on. Let's do. Okay, factor that one.
I also like my parents.
What relevance does that have to anything we're doing right now? I asked you a question. What relevance does that have to do with anything? So why did you I'm sorry? Well, we're going to lock that down. Good job.
Oh my gosh, yeah.
I did it right, so. I do 5 and 2 would equal 7. Maybe 5 and 8 would equal 7. 5 times 2. I'm God tier, I love this. I know, I love it. Yo. So look at this. -7, you have to do 5 and 2 is also another option because 5 times 2 equals 10. So you can find something that when multiplied by each other it gets the C. Or when added by each other it gets 10. So 5 times 2 is 10. 5 plus 2 is 10. No, because it doesn't equal 10. 1 times fraction is equal to -7. Instead, you could just do the OI, my dude. Click the back button, click the back button. And then it can say X times. Then you do the inside. And then that equals -7. So you know
Okay, so we've got an answer up there, and you'll notice that when you're factoring things like this, there's not a lot of work to show. So breaking down the x's, fine, we're not even going to bother checking that. Because it's a minus plus, we know it's going to be minus minus in the parentheses. She's good to go so far. -2 times -5 is 10, which we're good. Now we check the OI term. -5x plus -2x is in fact -7x, so we're all good to go. Okay. Any
I don't
problems?
understand how the two, because like, we got like 5.
Go ahead.
Because like, well, because we got 5 and 2, 5 and 2. Then like, this is -7. Oh wait, I know why.
Are you talking about your order being different?
Yeah.
Okay, so hopefully by now we all realize that A times B is the same thing as B times A, yes? So therefore, you could have x minus 5 times x minus 2. It's the same answer. The most common mistake that people make early on factoring is not necessarily knowing that two numbers multiplied together give you 10 and -7. It's a sign error. So having a plus on one and a minus on the other when they should both be minus. That's why this checking the OI term becomes important. You don't have to multiply the whole thing out. I'm not suggesting that if you're doing this first problem, you then come back here and say, okay, let's see, FOIL method, that's first, outer, inner, last, which gives me x squared minus 2x minus, oh, I'm good to go. You don't have to multiply it back out, but when the problems get more complicated, if you check that OI term, that will act as a quick check to make sure you have the right answer. Now, if you want to multiply every one of these out, that's okay. However, notice that in this problem, this is my answer, not the that just takes me back to where I started. So make sure you have that, those two factors broken down. Okay. GCF first, because you're going to see some fairly complicated problems, but if you just factor out a GCF, you'll be good to go. Okay. Tomorrow, we'll put a leading coefficient in front of that, and we'll talk about different approaches to the same types of problems. And then, no, not tomorrow, I'm sorry, probably Wednesday, because tomorrow we have the quiz. We'll go over this homework and then take the quiz. And then Wednesday we'll put leading coefficients. Thursday we'll start making these equations and start solving them. We'll also look at what the graphs look like if we start graphing these equations to see that parabolic shape. Okay, either up or down. Question?
Wait, is the quiz on exponents in this?
Radicals, exponents, and anything we've covered. This is not on the quiz tomorrow. Okay? Any other questions? Outstanding. Let me unlock day 11 for you. You can get started on that bad boy.